Thank you so much. It's wonderful to be here. So I'm Julie Shah, and I'm wearing multiple hats or multiple roles here today. So I'm an AI researcher. I'm a roboticist. I run the Interactive Robotics Group as a part of the Computer Science and Artificial Intelligence Laboratory. And I also have a role as Associate Dean of Social and Ethical Responsibilities of Computing at MIT within the Schwarzman College of Computing. And so as a roboticist, I can't come to you without showing robot videos. So what I'm going to do is talk a little bit about my own research and use that to introduce this new project that we have as a part of the College of Computing to develop new tools, resources for responsible research in computing, robotics, AI. And so I've worked for, I can do this here, I think. Next, let's try that. So I've worked for many years in robotics or manufacturing. I work on developing AI models that model people, model how people work, their physical workflow, their cognitive state, their personal priorities and preferences. I develop and deploy collaborative robots that work alongside people in factories, for example, to help build planes or build cars. I also work in developing intelligent decision support, so systems that are able to model human cognitive state, anticipate decisions that people will make, for example, provide the right information at the right time to support nurses and doctors, pilots, and other sort of high-performing teams. And so, in my career, I've really enjoyed working with industry collaborators, developing systems that can provide value. So, freely mobile systems that are able to maneuver around people outside of the cage safely to work alongside people in, for example, automotive. Systems that are able to negotiate shared physical space, coordinate with people, so make more flexible use of space. A person needs to come into the space, the robot needs to slow and stop, the robot needs to maneuver around the person to make more efficient use of the physical resources available in a plant, improve productivity, improve efficiency. And then systems that are able to monitor human workflow, anticipate where a person will be, what they'll be doing, and then be able to use that within a paradigm of dynamic plan execution to plan online to support people. And so the vision behind my own lab's work is to develop computing that augments human capability in a variety of ways. And so you can imagine how excited I was, I guess a few weeks or a few months ago when this goal was elevated to the national discourse at President Biden's speech on sort of infrastructure. I won't play the clip here, but he talks about design of the next generation of advanced manufacturing equipment, creating technologies that work alongside workers instead of replacing workers. So this seems to dovetail very well with the research that I do. In fact, I'm developing capabilities to exactly achieve that. But what does achieving that mean? So here's the question. What does it mean to work alongside? What does it mean to support? What does it mean to augment? What is our objective function or our goal here? How do we know if we're successful in achieving this? Is it a matter of really placing a robot alongside a person? What are our societal objectives, and how do we make concrete decisions in terms of our design and implementation to achieve a variety of goals? So as I mentioned, I'm Associate Dean of what we call SERC, Social and Ethical Responsibilities of Computing, along with my colleague David Kaiser in Science, Technology, Society, and Physics. And we have a mandate to envision how we can actively weave social, ethical, and policy considerations into the teaching, research, and implementation of computing here at MIT and also more broadly. So our efforts span both research efforts, catalyzing research, engaging in and developing new pedagogical materials for our teaching here at MIT, as well as building and catalyzing partnerships with external stakeholders. So within SERC, it's not just about, although that's a part of it, it's not just about putting the guardrails on technology and deciding what we should or shouldn't do, but in developing and creating and doing that across disciplines and also in ways that reach beyond academia, which is very important to our research enterprise and what we're aiming to accomplish here. And so I want to highlight, in particular, the efforts we have underway in responsible research, in developing the tools, materials, resources not just in training up our students, and I'll talk a little bit about how we do that, but how do we make sort of new modes of conducting research the norm here? And we do this, again, collaboration across disciplines. We have what we call the Ethical Computing Protocol, which is a process developed out of our philosophy department here at MIT, pioneered by Abby Jakes and Milo Phillips-Brown. Milo Phillips-Brown was our very first CERC postdoc. He's now faculty in both philosophy and computer science at Oxford. And they really pioneered this protocol, which draws from a robust literature and history in value-sensitive design and participatory design. And is a process that we now teach in a number of courses in ECS and other places across MIT. And in our efforts in CERC, in terms of what ECP is, it's a very structured process to think about the benefits and burdens of your proposed research, from the data that's collected, how it's used, the models, their implementation, to the wider set of implications it can have for various stakeholders. And the goal is to make this something that is very practical, is something that sits alongside the development and design decisions that I, as an engineer, make on a daily basis with my team. If Milo and Abby are here, they would give you a different version of a talk of this, as philosophers. And so I'm bringing you sort of the technologist perspective on how this is so valuable and useful. With an expanded team, including Ode, Ben Armstrong, Dave Kaiser, and myself, we're now actively working to make these materials something that's not just taught in a highly facilitated fashion in our courses, workshop style, but is something that can stand alone as a publicly available resource, but still interactive and still structured such that research groups here at MIT and elsewhere, as well as a number of other stakeholders and partners we work with and potentially you can make use of in practice. So everything we're doing is about experimentation. We're beta testing, understanding how variations of this become useful in practice in a variety of fields and a variety of disciplines. So this is a preview. We're anticipating this is going to launch within the span of weeks, not months, so the ethical computing platform. And I'm going to give you a preview of some of the steps. And as I mentioned, we're beta testing in collaboration with a number of different partners, professional organizations, and industry research partners. So the key aspects to think about in developing a new technology are what are the inputs, their implementation and deployment, and then their downstream effects and consequences. Within computing, we have a big lever point in terms of our problem framing and our value framing. We have very concrete questions we have in data generation and cultivation and, for example, labeling that are inputs to these systems that we develop. We have a variety of choices in terms of model and algorithmic choice that have significant implications for their implementation, deployment, and downstream effects and consequences. Increasingly, transparency and communication is important, both to be able to communicate these technologies and their boundaries to a variety of stakeholders, but also for assured or sort of safety critical applications. And then finally, understanding what these technologies can mean, envision these possible features at scale and impact. So the ethical computing protocol has 4 steps. The first is envisioning futures. The second is capturing values. The third is then mapping those values to decisions, design decisions, implementation decisions, deployment decisions, and then among those decisions, deciding and then being able to justify. And so the starting points, what we're often told as we work on this with our variety of partners is that there's this question of, if you can think of the problem in advance, then there's a series of steps. We know how to address it. We're engineers, we can solve the problem. But how do we ensure that we're identifying all the potential, not like over various timescales, over various geographic reasons for a variety of stakeholders that we may or may not have familiarity with, all of the potential issues that can unfold with a new technology. And this is where this process really excels. It's really a sort of a step-by-step sort of toolkit set of questions you ask, spreadsheets, sort of tables to be able to work through a more structured process to expand your thinking on envisioning these possible futures. So to give a sense, we start with who is your project for, what is it for, what problem are we trying to solve? in my own research, that's a great question, and answers to these questions really influence at a high level the ways that we shape technology and the impact that they can have and how they're used. So, many of you may remember back in 2018, there was a lot of concern about the increasing role of robotics and automation. Some very well publicized studies indicated that as many as 60% of jobs are vulnerable to automation. We have these top-down studies. One industrial robot eliminates nearly 6 jobs in a community. Well, often in manufacturing, this is not uniformly the case in other industries, but in manufacturing, we do think about introducing automation to displace labor. And there's a very straightforward calculation for the business case in terms of the labor displacement calculation. And so, with that as the objective function, you may see a result like this. I think what's so interesting is while we think, our mind immediately goes to, this is the future we're envisioning. This is the problem we want to solve for. How easy it is to sort of, miss the key issue that ultimately will make or break what we're all aiming to do together. So as a part of the Work of the Future task force, my colleagues Suzanne Berger and Ben Armstrong, including engineers, including some on my team, conducted a series of bottom-up studies of what was happening. And in particular, they focused on small and medium enterprises. And the title of this gives you a clue. It's actually the opposite of the concern. So in many sectors, and especially in small and medium firms, it's not that robots are displacing, but we have a much more complex story. So, internationally, even in large firms, you see, in France, they employed actually more workers when robots were introduced. The introduction of robots in Canada resulted in a reduction in the number of managers, but an increase in production workers, so composition of the workforce. In Germany, there were changes in the workforce after the introduction of robots, and again, composition changes. In the US, actually, in some cases, those adopting robots offered higher wages to production workers, but it resulted in fewer jobs overall. And so the story here is that there's much more complexity here than robots just taking over jobs. But we don't really understand how this context matters in terms of robot adoption. In the same factory, you can have a firm that's super successful at deploying a robot in one setting, and then another robot sits in the dark in the corner, and they're not able to make it successfully perform a task. In other cases, 2 different firms produce 2 very different solutions to their automation challenges based on a variety of factors. And overall, there are starkly few robots. In small and medium firms in particular, which represent a very large percent of all manufacturing establishments in the US. The quote is, "We were surprised to find very few robots anywhere. Only less than 10% of US manufacturing establishments even have 1 robot. And even among the plants with more than 500 employees, fewer than half had any robots." And our colleagues, Suzanne and Ben, show that with their analysis of data, that there's this widening gap between small and medium firms and large firms in their ability to utilize these technologies. And we know that technological upgrading of these small and medium firms in a variety of ways is integrally linked to the competitiveness of these firms and for us nationally as well. And so, so really the problem we're aiming to solve here is not, is not the sort of labor displacement problem as cleanly, but what is it that we're aiming to achieve? And so that leads to a question of the second step in this ethical computing protocol is who is our project or our technology development or our company for? Who is involved in this? Who are we solving the problem for? And the key, as a part of the Work of the Future initiative here at MIT, I and others, have a goal that, our goal here is that we see rapidly advancing automation and computation, but that it also offers dignity, opportunity, and economic security for workers, in addition to benefits that you'd see for a firm. And so, the question here is, how can we vector towards this ideal win-win-win, as opposed to where we are today, which is this low wage, low skill, low productivity equilibrium for many of these firms. And the question that the ethical computing protocol walks through is, well, how could things go well? How could things go badly? And in particular, how do they go well or badly for whom? So what's at stake and for whom? There's no real, just objectively good or bad future. Everything is good or bad or both for someone. And so expanding this analysis at the beginning of the stakeholders affected by your project is really critically important. And so when we look at shaping technologies, whether it's back office automation or robotics and manufacturing, we have a variety of stakeholders, but even within the category of workers, a variety of stakeholders. Those that are directly involved in the redesign of what's currently manual work, those involved in directly programming or directing the systems, those involved in what we often see as sort of filling the holes when the system or automation isn't performing as expected, those responsible for extensibility, flexibility for the automation going forward. And depending on what goes well and poorly and for whom, we can have this really success story for flexible automation that's able to be adaptable to changes in the work context, and ideally one that has low skill requirements, incremental new training, but that opens up economic opportunities for workers in a firm. And so when we look at how things can go positively or poorly and for who, the protocol works through sort of three moral lenses, three ways that things can go well or poorly. So one is the one we would traditionally go to, which is compared to the starting state at the end, who ends up with what? And so sort of an outcomes lens. And this is the one, in terms of a cost-benefit analysis that we're most used to working through. And so, but there are other lenses as well, drawn from philosophical theory, and so it's equally important from an ethical perspective about how people are treated through the process. So a process lens is a second lens. How are stakeholders of all those different types that you enumerate treated on the way to the outcome? And whether or not the outcome is good or bad for them. This is an equally important perspective from an ethical standpoint. And then the third is fairness. So in the end, the benefits and burdens are distributed among those stakeholders. And so how are they distributed? And in particular, how do background conditions of marginalization, inequality, oppression, how are they reinforced? How are they retranscribed? How are they broken? And so across these three lenses, as a part of the protocol, there's, you're not just asked these three questions, but a very structured process for working through for each of your stakeholders. And the idea or concept here is that ultimately we make design decisions, and having this as sort of inputs to those design decisions can help us make better decisions. How do we justify our decisions to the most impacted groups is our goal here. And so in terms of the design decisions, in a manufacturing context, in a robotics context, the decisions we make on the particular design of the technology, the interface of the technology, the skill level required for programming that robot has implications for flexibility of that automation. It has implications for skills and training. How we integrate, an external integrator coming in versus upskilling within or bringing the expertise within to be able to deploy that system has implications for flexibility, skills and training. And ultimately, as I mentioned at the beginning, how we measure success is a really big leverage point. And so we have many examples in sort of the real world of a variety of different solutions, sort of from back office automation to robotics, of low-code solutions that provide an opportunity for technicians to shift from an operating role to one as sort of a supervisor of an automated cell. We have high-code solutions that require more engineering expertise up front, but maybe you're re-engineering your process in a more significant way and can gain better benefits from it through this larger investment. So a variety of pros and cons there in design decisions that we make. And one path to go toward is removing this sort of this sort of expertise that sits in the middle of someone that understands the process and then the robot that's ultimately deployed. So removing that automation expert and enabling this more direct programming with a smaller increment on training. So I promised you a robot video. So in our lab, we developed technologies that aim to break free of that sort of expert, that robotics expert. Robots are designed to be programmed by people that understand robots. And so how do you leverage someone who has domain expertise but not programming or robotics expertise? And so doing that through demonstration, showing the robot how to do a task, and then with AI, enabling the robot to intelligently query and ask for key information from the person. So in sort of complex temporal tasks, illustrated here by kind of setting a dinner table according to a variety of menus, with about 3 demonstrations and 2 queries, the robot can learn a temporal task specification for, in this case, I'm showing you setting of a dinner table. And then there's questions on integration, where we as designers have a lot of input. Are we designing these systems to be integrated by external consultants? Are they integrated in a way that's supported via bottom-up with workers as champions? Again, with different potential outcomes for the firm. Are those that do the work maybe focused on kind of small projects versus top-down, where you can make sort of larger process re-engineering decisions? What does this mean for flexibility down the line in terms of who in a firm has the control and ability to make changes to that automation? These different strategies I've seen both in manufacturing context and healthcare context in back office automation. And none of these are straightforward from a technology perspective. All these result in technology challenges for us. It is very difficult, even for a PhD at MIT, to understand after they program a robot what it will actually do. And to illustrate that, the way we do that is we set up a number of different scenarios and we see how does the motion planner behave. Via tools we can develop, we can invert that, and we can tell the robot, find environments where you have a particular behavior. You maintain a certain clearance from an object. And in doing so, in a traditional controller, we find because of small asymmetries in the robot's arm, you can result in strange behavior where the robot only ever reaches to one side of the table. You might look at that and say, why is this robot never reaching to the other side of the table? And with a small improvement based on that insight, you achieve the robot behavior that you want. So these are some examples of how envisioning futures, capturing values, following through the implications of that in very particular design decisions and shaping decisions in our research can really provide tools, lever points for sort of changing the equation as to who can utilize these tools, the skill set, and the flexibility they can afford a firm. And so the ethical computing protocol, as I mentioned, is widely used in a number of our classes here at MIT. The ethical computing protocol is a part of a portfolio of CERC material. Over the last calendar year, 2,100 students at MIT engaged with CERC material as a part of their classes, including our largest machine learning class here at MIT. So it's really exciting. The faculty, it's not just Dave Kaiser and I and Ode and others, but there's a large set of faculty that are involved in a variety of aspects of moving this forward. And it's incorporated into classes such as the Programming Design Studio, in addition to machine learning, to give you a sense of the versatility of the process. And so there's much you can find on OpenCourseWare, sort of looking at these assignments, these design reflections, really excellent interviews with faculty that are incorporating this into their classes, Professor Daniel Jackson with the superstar grad student Serena Booth. And the OCW site for CERC features a number of these materials as well. So what we hope that you are looking forward to is the development of these materials into a platform that is not just suitable for our undergrads or our grad students here, but becomes over time something that's more suitable for use in a cadence that's appropriate for industry and other practice. We have really excellent partnerships with professional organizations, a current set of industry research partners, and we're very delighted. This is a real opportunity for us to learn how to make this useful in practice, how it relates to your current processes, and also be able to contribute back to the commons and flow back and train our students so that we send you even more prepared students. So please do reach out if this is something that's interesting to you, and we'd be delighted to talk about a variety of potential partnerships. And with that, I can wrap up and take any questions. Thank you so much. Okay, so first question, could the protocol be applied to other organizational transformation and public projects beyond ICT? The process actually, the ethical computing protocol was originally taught and is very applicable to technology more broadly. So it was developed and is currently taught in ethics of technology classes here at MIT. And its history from value-sensitive design is applied very widely. Participatory design has a long history in other fields and in engineering. There's a growing field of participatory design and value-sensitive design in computing and machine learning, which is really exciting, a very important and emerging area. But that's a long answer to your question, which is, yes, the protocol is really broadly applicable. Have concerns of widening economic inequality been thought about in this protocol? This is, depending on the project, the sector that you're dealing with, the set of questions are meant to be relevant and exercise and draw out these considerations across a variety of implementation efforts or technologies. Some are going to be more directly related to this question. For example, future of work, robotics and automation is related directly to this question of widening economic inequality. From a research perspective, this is something that we have deep engagement on here at MIT. Most recently from the task force led by David Otter, Liz Reynolds, and David Mendel, and the work that we're carrying on beyond that task force. Is there a way to frame the protocol in such a way that it's seen as a benefit to a company's shareholder value? And how would someone present the case to invest in the protocol to their CEO? This is a great question. This is the question. So now I'll tell you, for whoever asked this question, please reach out. So with this protocol, we have what I would say is a hypothesis that engaging with this protocol provides results in higher quality output for a project, for a company. We have ways of looking at this in the classroom in terms of like student projects and assessing those. We want to take these types of studies out to the real world and really test this hypothesis. And this is a key part of the research agenda related to the ethical computing protocol. And so in our view, this type of process, all of us think about stakeholders in development of technologies, right? In some ways, this is a process of widening the stakeholders that we're considering at the beginning. And it's a process that, in my view, and the view of others working on this, should really be thought of as sitting alongside a quality process, a quality assurance process. This is another dimension of ultimately quality of what we're doing. And ultimately, that is something we believe, and we've been developing an instrument to be able to measure. So those that might be interested in working with us to field this protocol and try to measure and test this hypothesis, we would be very excited to work together. Why does the resistance to automation, the image of robots as job killers, persist in popular culture versus the resistance to social media that turns us into robots? Yeah, this is a great question. So, the image of robots as job killers, it does not transcend nations. So culturally, different countries have sort of different conceptions or views of the role of these technologies in their society, and they also invest in different ways. Back in 2018, the sort of fixation on robots taking jobs was not echoed, for example, when researchers went and studied their utilization in Germany, for example. France is also another country you saw that looked at. They have a different orientation to technology. Japan is another one as well. So this is not universal or worldwide. And there are also, and I think that also gives an indication that by breaking free of that and really understanding this much more complex design space, we afford ourselves a larger design space for our technologies. And maybe we should sort of break out of this US-centric sort of narrative that I think in some ways is really holding us back. In small and medium firms is a very concrete example of the way it's holding us back. Wonderful. Well, thank you so much.